Another way that we can analyze compounds is by looking at their mass percent composition. This is just the percentage of a compound's total mass that is due to a particular element. So a common way that we can calculate this is just through a chemical formula. So this is the formula given in a lot of textbooks. The mass percent of element X, whatever you're interested in, is equal to the mass of element X in 1 mole of compound over the mass of 1 mole of the compound. I hate this formula. It seems very, very confusing. So let's think about what it is really asking for. The mass of 1 mole of a compound is simply the molar mass. So let's just call it the molar mass. There's no point in making it confusing. If I want the mass of element X in 1 mole of the compound, I just need to figure out how many of X are in the compound and then multiply by its molar mass. So this is another way we can write this. The mass percent of element X, you just look at the number of the element in the compound, and then you multiply it by the molar mass of that particular element. And then you divide by the molar mass of the compound as a whole. So this is the molar mass of the element, this is the molar mass of the compound. And then because you're getting a percent, you multiply by 100 at the end. Once you have the mass percent composition, you can actually use it as a ratio or conversion factor. So we should understand the meaning of a mass percent in addition to just being able to calculate it. So if I'm told carbon tetrachloride is 92.192% chlorine by mass, I need to know that means, okay, if it's 92.192%, that means for every 100 grams of the whole compound, 92.192 of those grams is due to the chlorine. So we basically just put it over 100 and recognize that the number on the percentage refers to the element on top, and we always put 100 at the bottom. So that's what that really means. So let's look at first how to calculate mass percent composition and then how we could use it in a problem. So calculate the mass percent composition of oxygen in lithium sulfide. Okay, first things first. We got to write a formula for this compound. So we know we have lithium, who's +1, and sulfite, which is SO3 with a -2. So if we have a +1 and a -2, we can cha-cha across them. So we get Li2SO3. So that's my lithium sulfite. It's very important we're able to write the formula correctly, because otherwise, if our formula is wrong, obviously our mass percent is going to be incorrect as well. So for the mass percent composition, or I just abbreviate it percent mass, I look over here. I need the number of oxygen in the compound, that's 3, and I'm going to multiply by the molar mass of oxygen. So that's 15.999 grams per mole. So since it asks about oxygen, all the information on top is about the oxygen. On the bottom, I want the molar mass of the whole compound. So I'm going to add up 2 lithiums, 1 sulfur, and 3 oxygens. We know how to get our molar masses by now. So if I do that, I get 93.944 grams per mole. Again, this is just getting the molar mass of this guy, adding up 2 lithiums, 1 sulfur, and 3 oxygens should give me this. And then because I'm getting a percent, I'm going to multiply by 100%. So notice my grams per mole cancel, so that's why those units get ignored. I have a percent, so that's the unit I end up with. So I just do 3 times 15.999 divided by 93.944, and I get 51.091%. So the mass percent composition of oxygen in lithium sulfide is 51.091%. Check. Based on this, how many grams of oxygen are contained in 7.5 grams of lithium sulfide? So what we need to do now is take that ratio, or take that percentage, and recognize what ratio this represents. So when I say it's 51.091% oxygen, that means that for every 100 grams of the lithium sulfite, 51.091 grams of it is due to the oxygen. And now this just looks like a conversion factor. If I have 7.5 grams of lithium sulfite, I can get rid of those grams down here, and I can turn it into grams of oxygen using this relationship. So for every 100 grams of the lithium sulfite, 51.091 grams of it is going to be oxygen. So these units cancel. I get grams of oxygen, and if I do the math on that, I get 3.83. But since I had 2 sig figs here, I would round there, so I would call this 3.8 grams of oxygen. So I should be able to both calculate mass percent using the formula and use it as a conversion factor by converting that percentage back into a ratio and then using it appropriately.